So this tutorial is just going to be a walkthrough for the ggplot2.2.R file. So I'm basically just going to walk through what's inside this R file and then just highlight some important sections, but it's really your job to go in and look at all the examples and play around with the code, because I found it easiest to learn ggplot2 by coding things on my own. So this first section here, you can explore the diamonds dataset yourself. And then here is the code that I used to create the qplot and the ggplot plots in the introduction video. And then right here, you can explore the aesthetic mapping and the different types of geomes. So here we can create a scatter plot. You can see how we can create a histogram and the various other plots. Right here, I put a link to a website that lists all 30 of the geomes. It would take too long to talk about each of them, but right here is just an example of a few of them. So here's some code that goes through examples relating to the aesthetic function. So in the introduction video, I showed you how we can map species onto the color, size, shape, or alpha of the plot. We're using the iris dataset, and so here is the code that creates those plots. So here is color, here's alpha. And then this section just goes over the idea of creating layers. So here's an example of three lines of code that create the same plot. So from this point on, the rest of the R code is going to show you how to add those extra layers that I only talked about that help you create a more complicated plot. So the first thing here is scales, and so the scales layer allows you to manually adjust some of the aesthetics of the chart. So here's a basic plot that we're going to start with. And if we wanted to change the colors of the scale here, we can use this function called scale_color manual and give a list of values, which are the colors that we want to change it to. And we get different colors that we've specified in this list here. And so there are other things you can do, like change the shape of the points. We can edit the x-axis and the y-axis using something called scale_continuous, and so you can give a title and the limits. We can also add labels to the whole graph using something called labs. So I'm not going to talk about all of these, but you can explore them on your own. Make sure you look at the help page for these. The other thing I talked about was faceting, which is to display subsets of the data in different panels. So here we're showing carat versus price for each type of diamond cut. We can do horizontal strips or vertical strips depending on where you place the cut before or after this symbol. Stats are used to apply statistical transformations that summarize the data. So it's kind of like an alternative way to build a layer that's similar to the geome layer. So essentially, the stat function and the geome function both combined a stat with a geome to make a layer. So these two lines of code create the same plot. Here we can see. So the one function in stat that I'm going to talk about in depth is stat smooth, which is used to create a fitted line. So if you look at the help page for geome smooth or stat smooth, you'll see that they're listed as basically the same thing and they have the same arguments. So but they say that you should use geome smooth if you want to display the results in a non-standard geome. So basically what they mean by this is if you want your fitted line to not be a fitted line and have a different geometric shape. So we cannot specify a different shape with geome smooth because we've already specified that the geometry is going to be a smooth line. So if we just add geome smooth and geome point, we just get a smooth line and then points. Like this. So we would use a stat smooth function if we wanted a non-standard geome. So So let's say instead of a smooth line like this, we want it to be points instead. So this is an example of a non-standard geom with stat smooth. We can also do bars like this. The other thing to note about stat smooth is that the default method is the locally weighted scatterplot smoothing regression, but we can change it to the one that we're most familiar with, which is the LM, which stands for the least squares regression. And so if we run this code, we can get a fitted line. So here's just some other things that you can do with different stats layers. Another cool one to note right here is you can create your own function and use that to summarize your data. So I'll let you look at that on your own. The other layer we can add is called annotations, which I mean is pretty self-explanatory. You can add annotations onto the graph. So a cool thing I'm going to note here is that you can add a math notation onto your plot by using something called plot math. So you can look at that on your own. And then finally, there's something here called themes, which allow you to control the non-data elements of a ggplot object. So for themes, there are theme elements, and then there are theme functions here. So for theme elements, we can refer to individual attributes of a graphic that are independent of the data, like font size, axis text, grid lines, and the background of the legend. So what you do is you add the theme function, and then the arguments within them are different theme elements that you can use to edit the graph. So if I start with this basic plot here, and I want to modify the axes, I want to modify the background, the legend, and the grid, I can add a theme and then edit the theme elements within that. So if I run this, you can see what happens. So theme functions are different because they define the settings of a collection of theme elements. So basically all this stuff in here has already been specified. So there's a minimal theme, which looks like this. There's a classic theme, and there's the default theme, which is theme_gray, you can see here. There's an additional package called ggthemes, which I really like because they have these really fun themes. Like you can make it look like a Google Doc graph or a graph from Stata. And finally, this section here goes through saving plots and data sets that go along with the plots. So let's say I've created this really complicated plot here, and I save it to be P. Then I can simply use the save function and put P and then specify the file name, and then I'll have a file called diamonds.rdata in your working directory. We can also do that to save an image. Here we can use the function ggsave. And then finally, the really cool thing that you can do with your plots is you can use a function called ggplotly that comes with the plotly package, and you can create a ggplot and then just plug it into your ggplotly function, and you'll get an interactive plot like this. Finally, the section at the bottom here talks about a cool function from the plotly package called ggplotly. So you can make your graphs interactive by plugging in your plot into the ggplotly function. So here I've created a plot, and I've called it P, and here's what P looks like. If I put P into ggplotly, I'll get an interactive plot that looks like this. And here we can see the hover, which shows the caret, the price, and the cut.